Artificial intelligence is rapidly transforming the landscape of data center operations. This technological shift offers significant improvements across several key areas critical to modern infrastructure. The primary focus areas benefiting from AI integration include performance optimization, enhanced cybersecurity, and improved power efficiency. These elements are fundamental to the operation and sustainability of large-scale computing environments. AI achieves these improvements by leveraging sophisticated machine learning algorithms. These algorithms are capable of processing and interpreting complex patterns within vast datasets. Furthermore, AI utilizes advanced analytics techniques. This allows for deeper insights into operational data, enabling more informed and automated decision-making processes. The application of AI enables data centers to become inherently smarter. They can adapt to changing conditions and predict future needs with greater accuracy. This intelligence contributes directly to increased resilience within the data center infrastructure. Systems can anticipate and mitigate potential issues before they impact operations. Ultimately, AI supports greater sustainability in data center management. By optimizing resource usage, it helps reduce the environmental footprint of these energy-intensive facilities. The integration of AI marks a significant evolution, moving data centers towards more autonomous, efficient, and secure operations. AI plays a crucial role in optimizing the overall performance of data centers. It achieves this by analyzing massive volumes of operational data generated continuously. This data originates from diverse sources within the data center environment. It includes telemetry from servers, storage systems, and network devices. By analyzing this data, AI allows for the proactive identification of potential bottlenecks. It can pinpoint areas where performance is being constrained before issues become critical. Similarly, AI enables the proactive detection of performance degradation. It can spot subtle signs of declining efficiency that might be missed by traditional monitoring systems. AI-powered tools are capable of predicting future resource needs based on historical data and current trends. This predictive capability is vital for efficient capacity planning. This foresight facilitates the dynamic allocation of workloads across available resources. AI can automatically shift tasks to optimize utilization and performance. AI algorithms can also optimize server configurations in real time. They adjust settings to match the specific demands of running applications and services. The primary aim of these performance optimizations is to maximize resource utilization. Ensuring that computing, storage, and network assets are used effectively is key. Simultaneously, AI works to minimize latency for critical applications and services. Reducing delays is essential for delivering a responsive user experience. A notable real-world example of AI boosting performance is Google's deployment of DeepMind in their data centers. This implementation focused initially on optimizing cooling systems. Google's DeepMind achieved a remarkable 40% reduction in the energy consumed by cooling. This directly impacts operational costs and environmental sustainability. Beyond cooling, Google's AI deployment resulted in a significant boost in overall data center efficiency. This demonstrates the broader potential of AI for performance enhancement. AI facilitates automated infrastructure management. Routine tasks and complex adjustments can be handled by intelligent systems. This automation significantly reduces the need for manual intervention by human operators. It frees up staff to focus on higher-level strategic tasks. Minimizing manual involvement also helps to minimize the potential for human error. Automated systems execute tasks consistently and reliably. The result is faster response times to changing conditions or performance issues. Automated systems can react instantly compared to human-driven processes. Ultimately, improved performance and automation lead to enhanced service delivery. Data centers can provide more reliable and faster services to their users. Data centers represent prime targets for sophisticated cyber attacks due to the valuable data and critical infrastructure they house. Protecting them is paramount. In this challenging environment, AI serves as a powerful ally in defense. It provides capabilities that exceed traditional rule-based security systems. AI-driven security solutions are designed to analyze vast streams of network traffic in real time. They look for patterns and deviations from normal behavior. A core function is the identification of anomalies in network behavior. Unusual traffic patterns or system access attempts can signal a potential threat. These systems can detect malicious activities as they occur, often in real time. This speed is critical in mitigating the impact of fast-moving attacks. Machine learning algorithms are central to AI security. They learn from past attack data and known threat indicators. This learning capability enables the recognition of new and evolving threats. AI can identify novel attack vectors that haven't been seen before. By understanding emerging threats, AI allows for a more effective and rapid response. Security systems can adapt their defenses dynamically. AI offers significant advantages over traditional signature-based security systems. It can detect zero-day threats and polymorphic malware more effectively. A compelling real-world example is IBM's Cradar security intelligence platform. Cradar incorporates AI capabilities to enhance threat detection and response. IBM Cradar uses AI to analyze millions of security events generated across the network. It correlates disparate events to identify potential attack campaigns. The platform identifies potential threats by spotting suspicious patterns and behaviors that indicate malicious intent. IBM QRadar can also automate aspects of incident response. It can trigger alerts, isolate compromised systems, or block malicious traffic automatically. Beyond detection, AI helps in proactive vulnerability assessment. It can analyze system configurations and code for potential weaknesses. Identifying weaknesses before they are exploited is crucial for preventing breaches. AI can prioritize vulnerabilities based on risk. AI can automate routine security tasks such as patching systems. Ensuring software is up to date is a fundamental security practice. It also assists in automating configuration management. Maintaining secure and consistent system configurations reduces the attack surface. These AI-driven capabilities collectively reduce the overall attack surface of the data center. Fewer vulnerabilities mean fewer opportunities for attackers. Ultimately, integrating AI significantly improves the overall security posture of data centers. It provides a more dynamic and intelligent defense system. Data centers are notoriously energy-intensive facilities, consuming significant amounts of electricity for computing and cooling. Optimizing power usage is a major challenge. AI plays a crucial role in addressing this challenge by optimizing power consumption across the entire infrastructure. AI-powered systems continuously monitor energy usage patterns from various components. This includes servers, cooling units, and power distribution systems. They analyze these energy usage patterns to understand consumption trends and identify areas of waste. The analysis helps identify inefficiencies in energy use that might not be obvious through simple monitoring. AI can optimize cooling systems, which are often the largest consumers of energy in a data center. It adjusts temperature set points and airflow based on real-time conditions and predictions. It can also optimize power distribution units, PDUs, and uninterruptible power supplies, UPS. Ensuring power is delivered efficiently minimizes loss. AI can optimize server performance specifically for energy reduction. It can dynamically adjust CPU frequencies or put idle servers into low-power states. These optimizations directly reduce energy waste throughout the facility. Every watt saved contributes to lower costs and environmental impact. A significant real-world example is Microsoft's implementation of AI-driven cooling optimization in their data centers. Microsoft applied machine learning to predict temperature and pressure changes, allowing for more precise control of cooling infrastructure. This resulted in significant energy savings for Microsoft's data center operations. It demonstrated the practical benefits of AI in this domain. AI can predict future energy demands based on workload forecasts and historical data. This allows for proactive energy management. Predicting demand allows for proactive adjustments to power allocation. Resources can be provisioned just in time rather than over-provisioned constantly. This reduces the risk of over-provisioning power capacity, which is both costly and inefficient. Optimizing energy usage directly impacts the power usage effectiveness (PUE) metric. AI helps drive PUE closer to the ideal value of 1.0. By reducing energy consumption and improving PUE, AI helps data centers become more environmentally sustainable. It lowers their carbon footprint. Furthermore, improved power efficiency directly reduces operational costs. Energy is a major expense for data center operators. In conclusion, artificial intelligence is fundamentally revolutionizing data center operations. Its impact is profound and far-reaching. The key benefits realized through AI integration are significant: enhanced performance, strengthened cybersecurity, and improved power efficiency. Real-world deployments by major technology companies demonstrate the tangible benefits of AI in this domain. Examples like Google's DeepMind for cooling, IBM's QRadar for security, and Microsoft's cooling optimization highlight successful applications. AI creates smarter data centers capable of autonomous operation and intelligent resource management. It creates more secure data centers with advanced threat detection and response capabilities. Crucially, AI creates more sustainable data centers by optimizing energy consumption and reducing environmental impact. AI is paving the way for a more efficient digital future by optimizing the infrastructure that powers it. It is also paving the way for a more resilient digital future, ensuring that critical services remain available and secure. Hey, if you're enjoying this video and want to see more like it, don't forget to hit subscribe and turn on the notification bell so you never miss an update.